So what we learned yesterday about the virtual switch, right? So when we say the virtual switch, it is something that is being created in your hypervisor. Okay. And that's provide the virtual networking to my virtual machines. And my physical host, if traffic is going from outside of one ESXi host to another ESXi host, then that is taken care by mapping of the virtual switch with the physical network interface port, right? So let us suppose take a simple example again. If these are my ESXi hosts, under these we can create number of virtual switches, and we can map those virtual switches to available physical NICs to my ESXi host. So this is my ESXi host. These are my virtual switches as I'm assuming. Suppose that this is mapped with this is mapped with this. So same way, here is virtual switch 1, here is virtual switch 2, here is virtual switch 1, here is virtual switch 2. Okay. So what is the main function of virtual switch? To create a virtual switch, primarily each virtual switch have 3 type of ports. One is the port group. When we say port group, these port group primarily managing the VM traffic. And second is VM kernel port. That's primarily for hypervisor VM kernel function, kind of vMotion, vSAN, FT, iSCSI storage, blah, blah. And we have an uplink port. So when we say uplink ports are the available physical ports on my physical host that perform the mapping with your virtual switches as well as the physical switches. Suppose that these are my network switches. So the uplink design could be like this. One port go to one switch and another port go to another switch. All right. So there is 2 categories of primarily switches are standard virtual switch and the distributed switch. So when we say about standard virtual switch, we have to individually create the required standard virtual switch on each of the ESXi host, and also we have to done similar configuration. Like for example, I need to create number of virtual machine port groups, and same way I have to create the same thing on another host as well. So it will increase the lot of administrator efforts while we are creating the port groups or VM kernel port individually on each and every host. So when we say the distributed switch make life easier for VMware administrator. So our distributed switch primarily created on vCenter level, and that is replicated on each and every physical host as an hidden virtual switch. Okay. So when we create the distributed switch on vCenter server level, we have to map the available ESXi host first, which ESXi host are going to use this distributed switch. So same way, like there is some uplink, we have to create some DV uplink here. Like for an example, we have create 2 DV uplinks. So it means that we are assuming the physical host are going to use 2 uplinks that will take care of my traffic from outside of these hosts. Okay, so if two uplinks means is that I am creating two physical uplink. I am creating two physical uplink. As a next option in DVS, so this DVS primarily going to create a hidden virtual switch. When I say hidden, it will replicate the configuration in my available ESXi host, but we cannot manage the distributed virtual switch from host level. Okay, so if I need to create any port group, I have to create on DV switch. That port group will be automatically visible for your ESXi host whenever you are you are creating a virtual machine and you are assigning them. So for each of the function, whether that is for mapping different categories of virtual machine and for my VM kernel ports, it always create a port group. So like management, vMotion, vSAN, or maybe another VM kernel traffic that is managed by your ESXi host. But still, all the VM kernel port, see, this is the port group I have defined, but still I have to create the VM kernel port individually for each host. And during the creation, it will ask me for the respective port group. Let us suppose for these are the management port for each host. This is the vSAN port. This will go on another port. This will go on another port group here. So the respective VM kernel ports will be placed in respective VM kernel port groups that we have to create in distributed virtual switch. So by default, by nature, whenever you will prepare a ESXi host, each host will have a standard virtual switch inbuilt that is called SVS0, and that is mapped with one of the uplink. And as in default configuration, it have a virtual machine port group name is VM network, and also it have the one management VM kernel port. Function is, when I say VM kernel port, name is management and function is also management. That's the default nature. But if you will say near in future, sir, even I don't want to use this further extended virtual switch. In future, I want to migrate my management port also to my distributed switch. So for that, you have to create a port group first. Then you can migrate all the VM kernel ports or first management, then rest of the VM kernel port on DVS switch as well. And also, if in case you have configure your earlier your environment was in like standard virtual switch 0, standard virtual switch 1, you want to migrate all the VM networking from SVS to DS, that's also possible. That can be done from DS console itself. We will have an option migrate the virtual machine, and we will select the source port group as in my port group that is defined in SVS, and target port group I will define the port group that I have in distributed switch. Okay, so same way VM kernel port, we can trigger the VM kernel port migration also from SVS to DVS. So if you will see, I mean, it's all depend like how the people are using the environment. Sometimes people use SVS also, like primary for management function, and maybe for vMotion, maybe for vSAN, and for all virtual machine traffic, they use DSS. So this hybrid architecture altogether is possible. Okay. So when I say the hybrid architecture, it means that is it is an like as I said, some of the traffic will be managed by standard virtual switch, and some of the traffic will manage by, like this is my one host, this is my another host, this is the SVS0, and SVS0 only I am using for management purpose. that will definitely require some uplink. And same way here, this is my management, and also by default VMK port, sorry, that is VM network port, virtual machine port group. And the another configuration that I have configured the distributed switch, and that is going to create a hidden virtual switch, as I said here. So in any of the case for DS, we require the separate uplink. So in this hybrid architecture, some uplink I want for SVS and some uplink I want for DVS. Okay. So DVS traffic, standard virtual traffic, will be managed by physical link 1 and 2, and my DS traffic will be managed physical link 3 and 4. All right. So that's way also we can design an architecture. So it's all depend upon customer requirement. If he only wants DS, or he wants the hybrid model, SVS on for primarily for management and probably for another VMK traffic also, or DS only for the virtual machine port groups. Okay. And it could be also possible they are only using the VDS architecture. But when we are using VDS architecture, if we don't want any dependency on SV switch 0, in that case, we have to migrate the management VM kernel port somewhere on the DS, where we will create a port group by name of management, and I will migrate all VM kernel here. Or probably there is another VM kernel that could be migrated into the port group in DS, distributed switch. So it's all depend the customer requirement, how he wants to look up. But like normally best practice said to do normal many efforts and all, better is create only one switch. Okay, that will save your NIC requirement also, and all the traffic will be managed by DVS, and that will save your administration and management efforts also. Okay, all right. Any question from this? Are we good?
Yes, sir.
Yes, sir.
Okay, cool. So today we are going to discuss further, like yesterday we read about the port group, switches category and all. So today we'll see this set of policies, this set of configurations we can perform inside a virtual switch. Okay. One second. Yeah, yesterday we were here and I was trying to telling you the sum of differences between standard and distributed switch. So when I say the difference, so where you see all these features are common. We can do port group, IPv6 support, we can perform NIC teaming, we can do outbound port traffic. So all these features are common. X means here available. These features are available in common. We could say common from features perspective in standard virtual switch as well as in distributed switch. So when we say the difference perspective, these are the features from difference perspective. Inbound traffic shaping, I'll talk in detail, but for an example here, in earlier slide, we have seen outbound traffic shaping. Outbound traffic shaping is only, is available for both. But when we say inbound traffic shaping, that is only available in distributed switch. VM network port block. It means is if we want to block a virtual port that is being consumed by a VM, that can be done in DVS switch only. Private VLAN, if we want to configure some private VLAN, we don't want to publish them outside, that we can do. Load-based NIC teaming, only we can do. This is another teaming policy that we will just read about it. Don't worry about that. Data center level management. So when we say data center level management, if in data center, I will create a DS. Suppose that I am consuming for this cluster 1. In cluster 1, I have 4 hosts. And also I want to consume the same distributed switch for cluster 2. That is also possible. If I have another clusters, that is also possible. Have for node or any, okay. So we can share the distributed switch across the cluster in a single data center. While in a standard virtual switch, those are the individual host level. Or if we have host in cluster 1 and host in cluster 2, then standard virtual switch cannot be shared, even within cluster also. vSphere vMotion of virtual machine networking state, that's told us like migrate from SVS to DVS, and we can migrate the VMs that's running in one cluster. And if we want to migrate in second cluster where DVS is same configuration, so that's also possible. Per port policy, it means that we will have set of policies that we can apply on port group level, also an entire switch where the port group is exist. And DVS give you more granularity even for a specific virtual port that is consumed by a virtual machine. You can configure port group level policy also. Port state monitoring, what is happening with that port, that is used, unused, disable, net flow. For we have add some net flow tool, port mirroring, access to NSXT port group. It means that if we are using NSXT is the advanced networking that we can see in DS. The advanced networking that is being done by NSXT is another SDN component that cannot be seen in standard switch. So these are, if someone will ask you the difference, so these are the big list of differences you can describe between standard switch and distributed switch. And also the major differences that is being created on data center level, where I don't need to recreate the switch on each and every host individually as compared to standard switch. Okay. All right. So as I said, there is a different set of policies are available in switch: security policy, traffic shaping policy, NIC teaming policy, failover policy. That all we can configure inside the switches. Okay, let's talk about detail. What is these policies? So first of all, the kind of policies we are applying in a switch. So in a standard switch level, default policies are applied on ports on a standard switch. What it mean? It means that is like I have a switch here and I'm setting some set of policies. End of the day, this is any kind of policy. This is any security policy, traffic policy, NIP teaming policy, failover policy that is impacting a virtual port that is consuming by my virtual machine. So this is my port group and this is my virtual port that is being consumed by any of the virtual machine. Okay, so standard switch level we can configure, but if we want to override any policy that I have configured on switch level, I can also configure on port group level. So what it mean by port group? Like I have applied a policy, for example, any NIC teaming policy, or I have applied the another policy on port group level. So the port group level policy will override for that particular port group, will override the policy that we are getting from the switch level. Got it? So if in case we have, like on switch level, we have policy 1 with same definition. We have policy 2, policy 1 same, but one port group level. Then this policy will override the policy that is coming from the switch end. Got it? So now let us talk about the different set of policies like security, traffic teaming and all. So all these policies can be applied, as I said, on switch level as well as on port group level. So if we want to looking at any policies that we don't want on from switch level, we want different set of policies, then we can apply on port group. All right. So when we talk about security policy, there is three security policies are available by default on each port group. Those policies are coming from the switch level. But if you say, sir, for this particular port group, I want a change in the policy, then you will check override and you will get here two options. One is reject already and one is accept. Same way here, by default reject is selected. So these policies are by default coming from switch level policies. Same way you will get option reject, accept, reject, accept. Okay. So now let's understand what these three security policies do primarily and how they impact my virtual port that is consumed by the virtual machine. So when I say promiscuous mode, it means that you can allow a virtual switch or a port group for forward all traffic regardless of the destination. It means that if in case this is my port group and the policy is being applied, promiscuous mode accept. If promiscuous mode accept, it means is whenever any traffic will come to any of the machine, probably from outside, some traffic is coming for this machine one. There is some ping, RDP, SSH, HTTP, HTTPS, any request is coming. So if this mode is accept, what it will do, definitely this will go my virtual switch. It will try to find out the target machine. If any traffic will access by this port, by default that traffic will be copied to another port also. So if in case on any of the machine, I am using some network monitoring tool just to verify that what is being received by which virtual port, then you can easily track the traffic that is received inside this virtual switch by any of the virtual port. In this way, probably have you heard about hub? Hub was the networking device those was earlier introduced. That's the nature of hub by default. If any traffic is received on any physical port, that being broadcast. So same way here, if any traffic will be received here, that will be copied to another port also. If any network monitoring tool we are using, we can capture which port is receiving what kind of traffic. Okay. If I select by default mode is reject, if I will select reject, then only the traffic is coming for particular port that will be received by that port only. That will not be further copied or broadcast to another port. That is the function of promiscuous mode. Normally we keep it as by default setting is reject, but if in case there is some vulnerability attack or somebody is trying to hit some bug or traffic, so in that case we can enable it accept and put some monitoring tool, third-party monitoring, network monitoring tool on another machine, and we can capture the traffic is being received by another machine. Are we clear on it? Any doubt?
Sir, one question.
Hmm.
So why we enable promises mode? It will it's capture the traffic all the switch, but whatever we
No,
configure
no, no,
in
no.
our
In port group, yeah. I
in
told
sorry
you.
sorry in port group,
I'm
sorry.
talking about port group. Okay, whatever port groups come under the policy, The default setting is reject. Only enable is already are enable. See, policy is already enable. In policy, there is two options, reject or accept.
Okay.
Now you are seeing here reject. It means that this setting you are getting from switch level. But now you say, sir, for this particular port group, I want to override the setting. Check override. Select from drop down option, accept. When you accept it, traffic will start to broadcasting with all the ports. If you feel any vulnerabilities happen, anybody is trying undesiredly access to my VM available in this port group, who wants to do some level of monitoring, then we will enable it. Enable, not enable. No, enable is not right word. We will
We accept.
configure as accept. Okay.
Okay. So it is monitor the traffic only, right, sir? Whatever is coming in our virtual machine, so it's monitor.
It
For
nature is just to copy all the traffic. Now you need additional tool for monitor that traffic somewhere in additional another VMs so that you can capture the traffic. Simple example, if you are working on your desk, I am working on your desk, another is working on your desk, but in between your friend want to know what you are doing. So in that case, he will trace your call. He will say like whatever calls you are receiving, I should have that information as well. I want to monitor the things what you are doing. Same way here, if we put any monitoring tool in particular VM that want to know what is being accepted by another VMs also, then we can trace that traffic by doing the setting as an accept.
okay, sir.
Okay.
Okay.
So next point is MAC address change. So when I would say MAC address change, again, I will take by example, you will understand it better. Let us suppose again, this is my switch, virtual switch, or let us suppose this is my port group. This port group is somewhere is in virtual switch, and this virtual switch will be somewhere in any physical host, or somewhere this physical host will be connected by the network switches. Correct? That is the native architecture, right? So when I say MAC address change, what is meaning? So if I will create any VM, I will associate that VM to this port group, then definitely that VM will consume a virtual port. From here, correct? This is the virtual port. So the NIC we are connecting in these virtual machines, we refer as VNIC. So how these VNIC get the MAC address? It's an automatically assignment by your hypervisor. So MAC address is a two. It could be anything 0C like that. It is a 226 10 12 digit hexadecimal number that is being assigned by default by your hypervisor to any of the VM you will create. That will get a automatic MAC address to that virtual NIC by your hypervisor. Okay. So if so with the default NIC, this VM will get any inbound traffic, inbound incoming request or outbound. It is free to receive and send any data to any VMs internally or externally. All right. But if I would say MAC address change, under MAC address change, like today you say, sir, from this operating system, what is hosting inside it, I have changed this MAC address. You did anything? 2C1205, something like that. So you have changed the MAC address from operating system. Okay. All right. So once you change the MAC address, now it is the port group decision whether with this change, with this new MAC address, you should receive the traffic or not. What have to done with your incoming? If this option is reject, if this option is reject and you made change in this MAC address, then your incoming will be blocked, because your virtual switch will not accept the changed MAC address and it will not update to the neighbor switches that some MAC changes happen inside me. But if you will select this option accept and you change the MAC address by the operating system, then your incoming traffic will be allowed. No impact on the incoming traffic. In this case, this virtual switch will inform boss, I have a new MAC address along with the existing one. Don't block my incoming. So incoming block and outgoing will be decision by your virtual switch. All right. So you change the MAC, but if you select the reject, you are free to change the MAC, no problem. But incoming traffic will be blocked. But if you change, if this is accept, you change the MAC address from operating system, then no impact on the incoming traffic. Right? So by default, this setting is reject. But if we want, somehow I have some a use case, let me tell you, if we are using some load balancing applications. So any load balancing applications always receive a traffic on a load balancer. Then this traffic is managed by backend virtual machine. So that's the nature of load balancer, to distribute this traffic here and there. So if you are using any virtual load balancer in your end, your machine will not directly access the traffic. This will be received by this load balancer. So in that case, here we have to change this setting as an accept. All right. Are you clear on it? Accept or reject doesn't mean that you can change or you cannot change. You can change anyway. But what would be impact in your incoming traffic? If it is reject, your incoming traffic will be reject. If it is accept, your incoming traffic will be accepted. All right. So forced transmit, it is just a reverse policy with same definition. In this case, what will be done for your outgoing traffic if you change the MAC address? If you change the MAC address, you select this option as reject, then your outgoing will be blocked. Still incoming will be okay. But if you change the MAC address, under this setting, you have select this option accept, your outgoing will be continued. No impact. All right. Get it? Or any question? Are we clear on it? Because these are sometime bit tricky. We have to understand the meaning, the concept, how it works. But normally, I would say 80-90% cases, I didn't see any changes there. Whatever the default policy being configured, for all the policy, you could see a reject, reject, reject. Until unless there is no specific requirement, we don't make any changes. All right. So this security policy is, all these settings are available commonly in my VDS and SVS also. There is no much impact. Like you will get the same set of policies in standard switch as well as same set of policies in distributed switch also. All right, are we clear? Any question?
No, sir.
Next is the traffic shaping policy. So traffic shaping policy allows you the traffic send to outside to your network as well as for incoming. So here in this picture, you are seeing this is for outbound. This graph, this pictorial diagram is for outgoing traffic that's going outside from your virtual port to the physical switch. So this is my port group again. This is my virtual switch, and this switch is mapped with this. So we are creating, let us suppose here we are using 10 GB, here also we are using 10 GB. Out of this 10 GB, you are defining a policy for a virtual port, how my outgoing traffic will be managed. The bandwidth shape, the bandwidth shape. So normally we keep as one port active, one port standby. So for overall port group, how much bandwidth you have for now? 10 GB, because I have made this active and standby. So at a time, how much bandwidth can be consumed by a single, this 10 GB is allocated to my port group. Okay. For a single virtual port, I want to define some set of policies. Like there is 3 values you will get. What should be my average? What can be my peak bandwidth? So average rate we can define. We can define the peak rate and the burst size. When we say the burst size is bandwidth, the bandwidth being used at that and that particular point of time. Like for an example, a virtual port is using 5 GB of bandwidth by 5 seconds. Okay, then total consumption will be 25 GB. So if I will set burst size as 25 GB for it will calculate the bandwidth for 5 seconds. It cannot go within that time of period more than burst size bandwidth. Same way we can define peak. Peak will be always less than your burst size, and average could be any. Like for an example, you say the average consumption would be, average consumption or peak is per second. Okay, 5 GB, something like that. So again, normally people don't touch these policies ever. So if in case I am using DS, this traffic shaping policy, I can define for outbound, also for inbound. That's possible. This is the difference. The one I was telling you, inbound traffic shaping policy is only available with distributed switch, not with standard. However, outbound traffic policy is available for both standard as well as distributed. This is the traffic shaping policy. Again, what I said, on switch level, always this option is disabled, but if you want to override it, then you will be able to change it. So here, average bandwidth I have given 10. If you will calculate, it will come around 10 MB, KB, MB, GB. Then it is in, but you will see burst size. You will say, yes, sir, this value is more, but this is less. This is not actually less. First of all, this value is in bits per second. This value is in byte per second. Automatically, that value will be multiplied by 8 if in case we want to put something here. Because it in kilobits, it is in kilobyte. Okay. So if we want to enable, we can. But as I said, by default, this policy is disabled. End of the day, this policy is impacting a single virtual NIC. The limitations we are defining for incoming and outgoing traffic. In case of it is standard switch, this limitation can be defined for only the traffic is going outside, but for distributed switch, we can define this policy for outbound as well as inbound traffic. All right. Next is my network teaming policy. Network teaming policy and failover policy. This is the important one that typically use. So again, I will draw a picture here. We have discussed this multiple times for each port group. We are using it. There would be virtual switch that will be mapped with my physical host. And we always say that this will go to another switch. So now this policy is talking about how we are going to use or how we are going to consume these physical uplinks. Okay. So first of all, if we are using this uplink as active and this uplink as standby for this port group setting, then there is no meaning of this policy. Get it? Why? Because we are not doing any load balancing here. Only single port. How I can do with single active port with load balancing? Then there is no load balancing. But if I would say here, I am using both the adapters as an active. My VM NIC 0 is active. Also my VM NIC 1 is active. So it means that my traffic is balanced. Some of traffic is going from here and some of the traffic is going from here, from the above listed virtual machine. Okay. So now this policy is telling you how your traffic will be balanced between these active physical NICs. So when we say route based on originating virtual port. No, missing some slides. No problem. So when I say route based, now you assume this is my ESXi host and it is consuming 2 active physical NIC. This is my physical switch. Okay. So what it will do is whatever port group I am taking here, my LAN cards will register a virtual port ID in a sequence. Like first virtual port will create here, second virtual machine is starting the traffic that will register to second NIC, then third VM will register here, it will register a virtual port ID. So a virtual port ID will get created inside the physical NICs. So if next time this VM will send the traffic, let us suppose virtual port ID registered here, then traffic will go from this NIC only, until unless there is some problem happen with the NIC. So if problem is happen, then all my workload will be managed by the single active link. But if I will say failback yes, it means that once my faulty NIC will come back, the traffic was managed by this switch will again be back to manage by this. Okay. Then if you will drop down here, in case of it is standard switch, you will get two more policies, MAC hash, IP hash. So when I say MAC hash, in case of all my virtual NIC MAC address will be registered here, maybe second here, maybe third here, maybe fourth here. If we'll say IP hash, then my IP register will be learned by the physical NICs. And next time, if that VM wants to send some traffic to the target same VM or any VM, so it will always go by a single way. So it will never a flip-flop. When I say flip-flop, once MAC is registered here for this virtual NIC, then it will always prefer to go via this to avoid the more load and to avoid the flip-flop situations in my physical NICs. Okay. Again, I am repeating, all my load balancing policy will be applicable only and only once I will use two or more active uplinks. Then only load balance policies work. But if I would say active standby, then there is no meaning, because at one time I am only using one NIC. Then there is no sense of load balance policy. Okay, got it? Any question on it?
So whenever we create a virtual machine, the MAC address automatically updated here.
Where? Once machine will try to send the traffic outside of your ESXi host, then only
Okay.
MAC will be learned on this physical port. Next time, this machine will try to send some traffic outside world, then it will be pre-decided that it will go via physical NIC 1.
Okay.
The same mechanism will use for rest of the VMs. In case I would say IP hash, source machine IP and the target machine IP, learn here. If this machine next time will try to send the some info to this machine, it will not take another route. It will go only via this route. That is we called as an IP hash. Okay. Or when we are using DV switch, distant distributed switch, there would be one policy, physical load balancing. That you will get one more policy there. So what will be done in this case? Like VM will be balancing the load. If any of the host naturally will go more than 75%, it will automatically rebalance it. Like it will give the traffic to another one.
Okay.
So,
Suppose
yes, please.
there is first one is A and second one is B. Okay. And one of the virtual machine sending data from A. Okay. And receiving data from A only. Okay. Because there is means MAC address, there is means there is MAC address, MAC table has been created, something like that. Okay. So sometime if this A network, physical network port is like so much busy, so in that time it is possible that traffic can come from B
That is
network.
only when we set the physical load balancing, physical NIC load balance option. And physical NIC load balancer option is only available in distributed switch.
Okay.
And root
So
base originating virtual port ID is available in both. So the best practices is in a standard virtual switch, we always prefer to go root base originating virtual port ID. And in distributed switch, we set the teaming policies, physical load balancing.
so the question is that, okay, I understood the point. So from NIC A, one of the virtual machine sending data regularly and receiving. Okay. And anyhow, what happened? Oh,
Carry on.
anyhow, what happened? The port A is so much busy that the sender
Then your traffic will
sending.
be in queue. If you are using any of the policy, root base originating virtual port ID, MAC has or IP has. In that case, you have to wait. Waiting is not a
So
seconds of wait,
so
microseconds wait.
means data will be not passed from
Another one,
physical network
correct.
B
Absolutely.
because MAC address because there is no
MAC address registered with particular, correct, particular LAN card.
okay.
But if you are
So
using physical NIC load balancing option, then that restriction will get removed. It can come from
how
anywhere, it can go to anywhere. But this
so
policy is only available in distributed switch, not in standard switch. So in distributed switch, we will get 4 network teaming policy. In standard switch, we will get only 3.
so means like whenever so how MAC table like it keep the MAC table if any virtual
No, it's
machine
not, it's depend upon the policy what we have configured.
so it's automatically update the MAC table on both the physical switch when we are using distributed switch and when you are using this policy. Okay.
So when it is MAC has, so
This
my
is virtual
physical
machine
NIC,
A.
yeah,
Make
my
make it A.
physical NIC will learn the MAC address of this machine. If
Okay.
here in future, you need to send some data anywhere outside from this host, it will always prefer to go from NIC A.
Okay.
And if, for example, I have set the policy MAC has based policy, and this MAC is learned by this machine, anytime this machine will out, traffic will go out, it will go always via NIC B until unless there is no failure. Got it?
We got it, but suppose that virtual machine 1 is sending data from A. Okay.
Yes.
He
Okay.
he
Here is
never
the MAC address being updated, but only
updated.
whenever I have the make teaming policy MAC address base load balancing. In that case,
Okay.
only MAC will register here. But if I make this
Hmm.
policy IP has, IP address will register here. If I make root
Okay.
base originating virtual port, no IP, no MAC, it will create a random virtual port ID.
So as per best practice, what we are choosing?
Abhi to you
Road
just
based.
tell me na, you understand me in previous slide. You told me I
सर
understood
मेरे
your
को ये
point.
समझ नहीं आ रहा कि
Best practices when we use standard virtual switch, we always do root base originating virtual port in
okay
case of
means
standard switch. But in case DVS, we always prefer to go with physical NIC load balancing because it will do a load balance in a right way. Yeah, tell me if you have any question, please tell
yes
me.
question was asked by the interviewer only. Maybe doubt. Okay.
Now you are clear or not?
Clear, but there is one doubt.
No, there should
Then
not be on no but, Parveen.
see,
Ask
see,
me in any way.
this is the
Whatever in
virtual
your
machine.
mind, ask.
This is a virtual machine 1,
Hmm.
and second one is 2. Okay.
Yes.
Yes.
2.
Okay. Correct. So every time virtual machine 1 sending data from A. Okay.
Okay.
And receiving also data from A network.
Absolutely right. Okay.
What happened anyhow? What happened?
Hmm.
Somebody's like he is receiving means somebody is
First, you tell
sending the
me
data.
which policy you are using from here. Then only it will take the decision.
We are using distributed switch.
You are using distributed switch, but which teaming policy you are using? I told you na, in distributed switch you will find 4: root base originating virtual port ID, MAC has, IP has, physical NIC team load balancing. Correct? Now you tell me which policy you have select from here first.
Suppose that we
Then
are
only
using
it will take the decision how the traffic will go and in and out.
last one physical.
Physical NIC
Yes,
teaming
yes.
load balancing. Okay.
Yes.
Okay.
So So in that case, every time virtual machine one sending data from physical NIC A
हाँ
and receiving also. Anyhow what happen
हाँ
that whenever he means anybody sending data,
हाँ
he is not able to receive the data because physical port A is busy. In that case, what will be
See,
happen?
it will be only queue. Busy in networking, busy doesn't mean it will be busy for an hour or 2 hours.
Okay.
It
Yes.
is just a time of few
Nano.
micro nanoseconds. Yes.
Okay. Because like MAC address or means what is not registered over this
No,
network
no, no,
physical network.
no Mac, no Mac.
So
No
why it
Mac
is not
address.
transferring from B? Means
See,
why?
if you apply this policy, you are asking the consumption, right? It is for outgoing traffic. If you will say it goes beyond 75%, it will automatically switch to another NIC. That's the threshold value.
Okay.
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 So not learn every time Mac because Mac will only work when we will selecting the Mac address based NIC taming policy. Okay. IP, if we select the IP, it will take decision on the basis of source and destination IP address. If we select physical NIC, it's in random. But if any threshold will go beyond the value, then it will switch to another. But again, as I said, all the taming policy will be work. In that case, you have 2 or more NICs. Otherwise, there is no definition of taming policy. If you are using one active, one standby, then there is no definition of taming policy. Does not matter what taming policy you are using. Because you are using single NIC. If you are using single NIC for traffic in and out, then that's always a single NIC, right? Get my point?
Yes.
So
I understand that for teaming to physical NIC is required.
yes, 2 or more. So when we say failback means is simple. I just told you. If in case I am using 2 physical NICs, some of the VM traffic was managing by this, some of this, by any chance it got failed, the all traffic will redirect to this. If I will select failback yes, automatically the virtual machine which is redirected, they will back to the NIC 1. Okay. Load balancing option, exploit the failover, always use the VMNIC uplink at the top of active adapter. Okay, active adapter means is like uplink 1 should be VMNIC 0, uplink 2 should be VMNIC 1, in that way. So physical network consideration, always, as I told you yesterday, no trunking is enabled by default. VLAN NIC teaming protocol is there. VLAN tagging protocol is there. So we don't need to do any tagging. Sorry, we don't need to do any trunking on my virtual switch side. Only trunking we needed on the physical switch. That's all we have to factor. What security policy we are using. What is my neighbor? It is the non-Cisco or Cisco if Cisco. My virtual switch support both kind of discovery protocol, CDP and LLDP. So when I say CDP, the Cisco discovery protocol, if underlying switches are Cisco, my virtual switch will identify. If there is non-Cisco, then it will work. It will identify the neighbor switches by using LLDP. That's called link layer discovery protocol. Okay. LHCP, yeah, you don't need to talk much. Leave it for now. Yeah, that's how we can configure the different security policies in the switch. All right, so do we have some labs open here? Let me tell you where you need to play more. Module 2 again. Adding, configuring standard, adding. Oh, here. You have to do the labs from 2142 to. This all is theory for you till here. Till here means is everything is there, right? 2142 page number 358. Okay. 2142 358. Note down it. So this is again about theory part. Then it will start from here. Adding, configuring standard switch, working with DV and all. Let me show you if something is available there already. vSphere web client. You can see my screen, right? In HOL lab.
Yes, sir.
Okay, cool. So if I will go to any of the host and here I will go to networking section under the, not networking section, sorry, configure tab. Here I could see a tab of virtual switches. Okay. Inside this tab, virtual switches, I could see a standard virtual switch is default and even we cannot delete it. Are we using it for some purpose? Ideally, no, because no virtual switch ports map with the physical one. Here is a virtual machine, but that is not connected. I am using it and there is only one VM NIC being, one physical NIC being associated with it. So now you understand, this is my virtual switch. Under this, I have a port group. And under this, I have mapped this virtual switch with one of the physical NIC. Now you can ask me the question, sir, you told us in default virtual switch, there is also one management VM kernel, but we are not able to see that. This is because of that in this lab, my management VM kernel being migrated to distributed virtual switch. Okay. Now if I'll go a little bit up, you could see here a gray line, a gray area you could see till the bottom. So all this gray is my distributed switch. But again, did I create it from the host level? Answer is no. It is being created on data center level from vCenter console, not inside the ESXi console, not from here, something from networking place. So what is inside this DBS? Let us see what's being configured. So first thing you could see for this VDS, 2 uplinks being configured, right? How many? 2. It means that 2 physical NICs being used for utilize this distributed switch function. Then what is being created under this distributed switch? There is one port group, no VLAN, but that is for VM kernel ports. Let us see what is VM kernel port here. VMK 0. So that is, this is a port group, but this is being used for managing VM kernel port. And there is another port that is also VM kernel. There is another port group that is also for VM kernel. What it means? What this architecture is saying you? This architecture is saying you, so far, if you are consuming this distributed switch so far. Again, I'm repeating my word. This architecture is like this. If you have, this is my ESXi host, this is another ESXi host. ESXi host have one inbuilt switch that is mapped with the VMNIC 2 in this example, and we have a DV switch. Under DV switch, I could see number of port groups, but all these port groups are going to use for managing the VM kernel ports. So those so this DV switch will create a hidden virtual switch here. Out of these, there is some VM kernel ports are available on each of the host, and those VM kernel port are landing here. So this for DVA, for DV, two uplinks being used. To DV uplink, when I say to DV uplink, it means that you are going to consume two uplinks for the DV switch configuration. That is your architecture so far as per this lab diagram. There is only one, either it go via this, or there is again only one for standard, it go via this, because one NIC cannot be passed from two physical network switches. That's how your lab is looking like so far. Got it? Clear? This is what your lab is telling. I'm not telling you. This is what is your lab is telling. So now, if I will go to host, number of VM kernel adapters. So you could see 3 VM kernel adapter being configured. One is VM kernel 0, one is VMK1, one is for vMotion. So itself it's defining. This is my management VM kernel. This is my storage VM kernel, and this is being used for vMotion. So 3 VM kernel ports being used. Same architecture I will get on next host. But all these VM kernel ports are landing inside distributed switch. Okay. So now if I will go to networking tab, from here, I could see the available distributed switch. So this is my distributed switch. Okay. Under this distributed switch, here I can see 1, 2, 3, 4. 4 port groups are here. How many? 4 port groups are available here. If I will click any of the port group property, right click here, right click, edit. Let us see what is this. So it is configure ESXi region. This binding is this. Static binding means the virtual port will be fixed being consumed. Number of virtual port are 128, and that we can configure in it. So when I go to advanced, I told you, like when we were talking about VDS features, we can allow the policy change, all these policy change to individual port group also. Sorry, to individual virtual port. So if I will allow from here, I can go specific virtual port that is being consumed from this port group, and from for that particular virtual port, I can change the policy if in case those are allowed from the port group level. What is VLAN here? None so far. You can give the VLAN value also. Okay. Trunking and all that I will talk, don't worry. Security settings. So can you see what are the security settings here? Reject, reject, reject. Teaming and failover. Root-based original virtual port ID. Failure will be detected. Link status. Network switch notified. Failback. Yes. How many active uplink we are using here? 4. But out of 4, actually the physical links mapped with 2 as per this architecture. He took 4 dB uplink, but from physical switch so far only, from physical host so far only 2 uplinks being actually mapped. That I just show you on the host. Traffic shaping policy, I told you in DVS, we can configure traffic shaping on ingress and egress, but by default disable. Have we enabled net flow? No, but for enabling net flow, I have to just register some net flow tool appliance in some of the VMs, then only I can monitor it. Under miscellaneous, by default, block all ports option is no. If I'll click yes, all the ports will be blocked, no traffic will go, and I can do on virtual port level also. So, can I open VDS setting now? What is under this VDS? So, under this VDS, what is being available? This is the name of VDS. Uplink port 4, network IO control speed. I didn't define any IO control. It is using 4 uplink. But as per this architecture, it is showing I have only 2 physical uplink. I can do this 2 as well. That's not a problem. This is my MTU that a virtual port can send maximum traffic in bytes. The default discovery protocol is CDP. Because of that understanding, the hosts are using Cisco discovery protocol. And considering that all my NICs, these are 2 NICs being used here. If I'll click here, how you will identify? You would see under CDP or under LLDP, there should be some neighbors available. Okay, this lab is made in nested environment. That's why it is not short. But yes, if you will see in actual environment, either you will find some Cisco switches here. It will let you know for which physical port my physical NICs, these are my physical NICs being associated. It will showcase you here. All right, then let me go back to this. This is vMotion. So if in case I'll go back here, and if you say, sir, how could you say this is the VM kernel port and all? So if I will click here, I will check this setting. So this VM kernel port, the function is VM kernel and name is this, but function is management, right? These all are the categories we can create. So here, this VM kernel port is being used for management. If I'll click here, let us see the function. This is being created, but actually it is not being used for any purpose so far because there is no option being selected. Same way, let us check for vMotion. It is created for vMotion and it is purpose of vMotion. So how these all VM kernel ports are landing? These VM kernel ports are landing inside these port groups. If I would say here vMotion and I will try to check the ports being used. One port is being used here, 256, and there is another port also. Yeah, there should be 2. Are you agree with me or not? By how many hosts you have? 2. On these 2 hosts, you have created 2 VM kernel port. Where those ports are landing? Inside this port group. Are they consuming? Yes, they are. This one port is consuming here, and another port is consuming here. Now you will say, sir, answer is one port group have 128. Yeah, you are right, because counting is starting from here 250, 256. So virtual port assignation could be random. Same way, if we will see here to this port group, this port group is actually your virtual to align the virtual machines only. You could see here, these are two virtual machines, two virtual port consumed here. This is for landing your VMK again. How you are identifying? That is for VMK. I just show you these hosts. Under this, I am not seeing any virtual machine. Are you seeing? Nothing. Only the ports are used for host, not by the virtual machine. Same way here, some of the virtual port being consumed. All these are the VM kernel category, but this port group is created for virtual machines. You could see here, name are virtual machine. If you will click here, also you will get listed VMs. Those are connected to this virtual machine port group. So what is the architecture of this DVS? This DVS for now having how many port groups? Any answer? How many port groups are
Four.
there? Four.
Sir, 4.
Correct. And all these three are used for landing the VM kernel port. One is for management, one is for vMotion, one is for storage. There is another port group also that is for managing the virtual machine traffic. Correct? And the host which are designed under this like this. Same way the VM kernel here are so far. I'm saying so far. There is few VMs. I don't know where those VMs are hosted, on which host, but yes, they are consuming some of the virtual port. Physically, those VM will be on your host, definitely, but I'm saying for port consumption. That's the architecture. Correct? That is what we are using. You understood or not?
Yes, sir. Understood.
Cool.
Yes.
So now I would request you guys play around these labs. You will get, because all these tasks what I'm going to show you by hands on, that's all being covered here. And you will learn each and everything. If still you have some doubt after doing these labs, we will definitely cover that tomorrow. But focused on from 2142 to 358. Correct? Complete all these labs. All right. Will you do that? Yes, no?
Yes, sir. Will
Sure,
do.
sir. Yes.
Yeah, definitely. Cool. Have a good luck ahead. Perform the lab instructions very carefully. Read each and every options, what is available where, what it is doing. So it's telling you creating DB switch, port group, setting policy. It's telling you all. But yeah, if in case in between you have some doubt, when complete the lab, note down your doubt. Okay. And note down the option, maybe take a screenshot or something like that and talk to me tomorrow. All right. So tomorrow is Saturday. Are you guys available?
Yes, sir.
Everyone?
No, sir. Actually, I'm going out. So if it is possible, we
You
can
do the
start on
labs.
Monday.
Tomorrow we will do only some clarifications. Okay. So we will record that session also. Don't worry about that. And then you can hear that. And if you have some doubt, you can ask later also. Will that be fine?
Sure. Okay.
Yeah. Cool. Make sense? So